so the first problem is this. Okay. While on a beach vacation, oh, sounds so nice. Tasha makes a scale drawing of points of interest between two piers. Just to let you guys know, piers are like, they're like, so it's like the beach, and there's a pier that goes like into the ocean this way. It's like a big old dock. And then there's a pier that goes this way, all right? Or maybe they're up on the, I don't know. Anyway, they're points on the beach. So on her drawing, 2 centimeters represents 5/10 of a mile, a half a mile. The piers are 12 centimeters apart on her drawing. What is the actual distance between the two piers? All right, so go ahead and start working that off. Let's work on that. Okay, so here we go. Now, I'm going to show you 2 different ways to do this, because I think a lot of you guys might have done it this way. So this is basically what this packet is. It's like a chapter review. All right, so it's a combination of everything. We are not doing this whole packet. I'm picking and choosing problems. So if you did this.
Bro, is that the office thing?
All right. First of all, A, not bro. All right, B, here we go. So this is going to be the drawing. So this is going to be in centimeters, and this is going to represent our miles. So what we know is that 2 centimeters equals 5/10 of a mile, right? The pier is 12 centimeters. So if I keep going up 4, 6, 8, 10, 12, this is what I want to get to. So down here, 5/10, 1, 1 and 5/10, 2, 2 and 5/10, 3. So this would be it. All right, so some of you guys might have drawn like a knuckle line or done it that way in your brain, right? So second method. The second method that I want you guys to start getting used to is doing and finding, so the scale factor. So our scale says 2 centimeters to 5/10 of a mile, right? Isn't that what our scale is? So if we were to find our scale factor, to find the scale factor, it's always the actual distance over the drawing. So the actual is 5/10. The drawing is 2, and we divide those. So 5/10 divided by 2 comes out to be 2,500. So what we know is that there's 2,500 for every 1 centimeter. That's what the scale factor means. So all we're going to do is take the 2,500, multiply it by 12, and the answer is 3 miles. Okay. All right. So good job, groups that got that. You guys get 1 point. All right. Moving on. Ready? Problem number 3. So we're skipping 2. Problem number 3 says this. Amber is making a scale drawing of a movie screen. The actual dimensions of the movie screen in her theater are 60 feet wide and 20 feet tall. In her scale drawing, the screen has a width of 9. So in her drawing, the width is 9. What is the height of the screen on her drawing? Okay, so again, you're collaborating. So many amazing ways of solving this problem today. This is what I heard the most of. Okay, and in order to share this with you, I'm going to draw out a picture. Okay, and I would recommend you guys every time when you have problems like this, draw a picture. Every time, it's going to make it so much easier to visually see what's happening. So here's the actual movie theater. Right, and the actual is 60 feet wide and 20 feet tall, right? Here's the drawing. So what I saw you guys said, oh, wait a minute. Okay. Okay. If we took 20 and you multiplied it by 3, that gave you 60. So here's the scoop. You found this a scale factor, but your scale factor was length to width. It wasn't actual to drawing. Can you do that? Yeah, absolutely. You can find the scale factor within the shape. The scale factor always doesn't have to go here to here. Your scale factor was length to width. All right, so now if you look at this right here is 9 inches, right? So what do you multiply 3 by to get 9? 3. All right, 3. So a lot of you guys solved that problem that way. I want to show you the other way. Are you ready? Okay, and if you could write this other method, if you have some room, please write this down as well. Okay, so So 60 feet, 20 feet, 9 inches, unknown. So we're going to look for the scale factor that goes from this length to the drawing's length, right? So our scale factor would be 60 divided by 9 because these are both of the lengths. So basically you're saying, okay, what do I do to 60 to get 9? Well, to figure that out, we're going to divide those. So 60 divided by 9 comes out to be, I forgot. So it's 6 2/3. That is my scale factor. 6 2/3 is the scale factor. So since I'm going from the actual down to the drawing, what do? Do I multiply or do I divide? When I go from the big to the small? Divide, right? So we're going to divide by the scale factor. So I'm going to divide by 6 2/3. So I'm going to take 20 divided by 6. ABC 2, ABC 3, and what do you know? We get 3 inches. Okay? All right. So 2 different methods. And the majority of you guys probably did it this way, and I'm okay with that. But I want you to understand how to find the scale factor of corresponding sides. Okay? All right. Last one from this section is on the back, and it's number 5. So it says, Emily works at a horse camp and makes a scale drawing of a barn. The width of this, you're not talking. The width of the stable in her drawing is 15 inches, and the length is 18 inches. The actual width, so this is her drawing. The actual width is 10 feet. What is the actual length? Again, I would draw this out. Drawing it out might help you understand this a little bit more. Okay, so go ahead. You guys have 4 to go through this. So, again, highly recommend that you draw this out. So here's her drawing. Her drawing is 15 inches in width and 18 inches in length. The actual width, right? The actual width is 10. Okay, 10 feet. So I'm going to show you 2 ways that you guys did this. Pay attention. Stop. Okay. I saw a lot of people say, okay, well, what did I do to 15 to get 10? A lot of people looked at it that way. Actually, yeah. So they did 15 divided by 10 and said, oh, they divided it by 1 5/10. Okay. Because watch, if you were to take 15 and divide it by 1 5/10, what do we get? What do we get? 10, right? So that is a way of finding a scale factor. So we're going to do the same thing to 18. So we're gonna take 18 and divide it by 1 5/10, and we end up getting 12 feet. So that was one method. Now, if you did it the way that we've been doing things, eyes up here on the board, please. All right. Sorry, this should be over here. Okay. The other way is this. To find the scale factor, we've been talking about it over and over and over again. It's the actual over the drawing, which comes out to be 2/3. And I know one group did this. So our scale factor is 2/3. So what we're going to do is we are going to take 15 and we're going to multiply it by 2/3. Watch what happens when we do that. 15 times 2 ABC 3. Right? Isn't that what the length is? No. Can't see it. Oh, there it is. All right. So we're going to do the same thing with 18. Okay, which comes out to be 12. Okay, now if you guys remember, dividing by 1.5 is equivalent to 3/2. Look at the similarities between those two. When you divide, you do the reciprocal. When you multiply, you keep it the same. Nice job, nice job, nice job. Okay, flip it over. Here we go. Let's talk about barbecue.
Okay, great.
Okay, so here we go. After making several scale drawings, Joseph decides the best placement for his fancy new grill on his deck. He uses a scale. Listen to the scale. For every 2 centimeters on the drawing, it's really 5 inches in real life. What is the actual area of the space for Joseph's new grill in square inches? Okay, we're looking for area. Go. Okay, so here we go. So again, the cool thing about this is there's 2 ways of getting the answer to this. And so actually, your group over there, if you would have stayed with what you did, it would have still worked out. Okay. All right. So one method, and I'm going to be honest with you guys, this method to me seems harder. Method number 1 is where you find the area of the shape that you're dealing with, right? On the drawing. Eyes up here. Okay. So find the area. Area of a rectangle is what? Length times width. So area of this is 10 times 18. So the area is 180 centimeters squared, right? But this is the area on the drawing. And the problem is asking us to find the actual area. So we need to find our scale factor. We need to find out how much bigger it is. Well, here's what we know. For every 5 inches in the actual is 2 centimeters on the drawing. So if I go 5 divided by 2, what do I get? 2.5, 2 and 5 tenths. There's my scale factor. So with that being said, I know that this side has to be multiplied by my scale factor, as does this. So it's really 2.5 times 2.5, which comes out to be 6 2/2500. So the area from this drawing, your zoning, pay attention, to the real drawing is 6 2/2500 times larger. So we would just take the area of the drawing and times it by 6 2/2500, and we get 1,125 feet or inches squared. Okay, again, like I said, I don't like that method, but if you understand that method, then you need to use it. Method number 2. Method number 2 is to find the actual dimensions. So again, you have to find your scale factor, right? By actual over drawing, so it's still 5/2, which is 2.5. So there's our scale factor. So then we're going to take the length or the width, whatever you want to call it. Okay, and this becomes 25. Take the width or the length, whatever you want to call it, times the scale factor, and I don't know what that, 45. And then we find the area of the two. So 25 times 45 still comes out to be 1,125 feet or inches squared. Okay, so doesn't matter what method you choose. Just be careful with this one because a lot of times we forget that we have to double the scale factor. Not double it, but multiply it by itself. All right. The last one in this section is number 4. Okay, we'll see how much time we have after this. So here's what this says. A scale drawing of a house shows a closet with 4 dimensions of a 4 centimeters by 3 2/10 of a centimeter. The scale from the drawing to the actual is 2 centimeters for every 1 meter. So it's drawing to actual is 2 centimeters to 1 meter. But remember, when finding scale factors, that's flip-flop. The question asks, what is the actual area of the closet floor? This one's a tad bit tricky. Right, make sure your masks stay up over your noses, please. All right, and go ahead and solve it. So look at this. All right, so here it is. So a scale from the house, the scale drawing of the house shows a closet with a 4 dimension of 4 4/10 by 3 2/10. Again, just because I am who I am, I want to draw this out. Okay, next. The scale from the drawing to the actual closet is 2 centimeters to 1 meter. But remember, when we talk about scale factor is always actual over the drawing. So if I reverse this, it would be 1 over 2. Well, what's 1 divided by 2?
2. 25.
Yep. So what's my scale factor? 5/10, right? Half. So step number 1, I'm going to convert these into the actual thing. So I'm going to take 3 2/10 and multiply it by 5/10. And I'm going to take 4 4/10 and multiply it by 5/10. So let's see what I get. 300 times 5/10 comes out to be 1 6/10. Okay, and that would be meters. So on the drawing, it's 3 2/10, but actually it's 1 6/10 of a meter. Okay, this one is 4 4/10 times 5/10. And this comes out to be 2 2/10 of a meter. But we're not done. All this shows us is what the actual dimensions are. Don't sound, pay attention. So the area of this is 1 6/10 times 2 2/10. And it comes out to be 3 52/100 meters squared. That's the area. Okay. So good job, good job, good job. All right. So I am going to have you try this problem. I'm not going to lie to you. It is challenging. All right. So ready? Here's what this says. The drawing represents a soccer field. So this is a soccer field with the goal areas on either end. The scale for the drawing is 5 meters for each grid unit. So see, this is 1 unit right there. So in real life, that would be 5 meters. You are going to draw another scale drawing of the field using a scale of 15 meters for every grid. Justify your drawing. Actually, and so when you guys take this up and write this on the board, you're going to draw the soccer field with the new dimensions. That's all you have to do. Okay? All right. All right, so looking at our answers. Oh, so, okay, so we have a couple of the same ones that if you look at this, listen,
It was.
the first thing is this. The drawing, the scale for the drawing to the actual thing is 5 meters for every unit grid, right? So therefore, if this side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's 21 units long, right? So if we were to take 21 and multiply it by 5, that comes out to be how much? 100. So therefore, the actual length of this side is 105 meters, right? Let's do this one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, on here, so to find the actual distance, it would be 15 times 5, which is 75. Okay, but now they say to us, well, wait a minute. We want to make a new drawing of this where the scale is for every 50 meters on the actual is only 1 on the new drawing that I'm going to draw out. So that means I'm going to take this 105 and divide it by 15. Okay, what's 105 divided by 15? What? It's 7. 105 divided by 15 comes out to be, nice job. So is 7. So 1, 2, 3, 4, 5, 6, 7. That's what the length is on my new drawing. So down here, same thing. I'm going to take the actual and divide it by the new scale factor. And what's 75 divided by 15? I think you're right. So 1, 2, 3, 4, 5. So here's what the new scale factor looks like. You guys see that? Yes.
We came up with 15 and 21. We got that.
But you just need to simplify.
You just need
Yeah,
to simplify it one more time.
Technically, it is right.
Yeah.
Close. All right. But like Mrs. Wilson said,
We're still.
there's another way of doing it, right? So each one of these is 5. Hold on. Gonna take a second to write these out. Lots of 5s happen in here. Lots of 5s. In fact, I should show her yours. Yours is a better explanation. So if we break these down into 15, right? How many 15s are there? How many groups of 5s are there that make 15? 1, 2, 3, 4, 5, 6, 7. So 7. So see? All right. So 5, 10, 15. One group. 5, 10, 15. 5, 10, 15. 5, 10, 15. So that is another method that you could have used to get your answer. Okay. So